Hi guys, how are you this evening? Hope you're all really doing well. I know this is a real delight in the current circumstances where we are able to link up via social websites, Zoom, Facebook, and so it's wonderful to be able to connect with all of you guys at this time. Just a few practical things throughout this session. If we can keep our mics on mute so that we don't interfere with the presentation. And if you have any questions, we will take them in the chat. So if you have any questions, just post them into the chat. But it's great to be able to connect this evening with you for tonight's event, which is an introduction into 3D printing. So my name is Kartar Singh, and I am part of the Sikh Museum Initiative team. Our vision, if you know anything about us, is very much about bringing to life Sikh history, Anglo Sikh history, through the use of technology, making it accessible to people all around the world, and really trying to inspire more people to connect with history and heritage. So this evening we will be having an introduction to 3D printing as part of our Anglo Sikh Virtual Museum project. For those of you who don't know our website, it's www.anglosikhmuseum.com. So please do, whenever you get a chance, check it out and see some of the objects and artifacts that we have got there. I'm delighted to be able to welcome Taran Singh from Taran 3D, who will be doing most of the presentation tonight, giving you an introduction into 3D printing and offering his expertise and insights into virtual technology. Now, Taran Singh is founder of the organization Taran 3D. He's an expert in 3D technologies. With 15 years experience in this field doing architectural engineering and some really fabulous work that I've been able to see over the last few years, but also about implementing 3D technology for this project, and that has been about bringing objects from Anglo Sikh history to life using virtual technology, augmented reality, and that's been a real game changer, I think, in the way that we view history and connect with history. From the fact that, with the current climate that we're in with coronavirus, many of us are not able to go to museums. This project is very much about bringing the museum to your home, to your phone, and making it accessible. So we'll begin the session with Taran, and if you have any questions throughout, just pop them into the chat, and either we will take them as we go through, or we will take them at the end. So Taran Singh, over to you.
Thank you very much, Kartar Singh. Yeah. So I'm just going to share my screen now so you can see the presentation. So if I share that, can you all see the presentation now?
Yeah.
Is that okay? Yeah.
Yeah, we can.
Yeah, that's brilliant. Fantastic. Yeah. So, okay. So, yeah, we're doing this as part of the Anglo Sikh Museum project. And what I'll do is I'll give you a quick idea. This is the website, anglosikhmuseum.com. And if you see this arrow here pointing to relics, if you go to this page, you can actually see a lot of the virtual objects that we've been creating as part of this project. So we've also done quite a bit of engagement with the project, taking our VR headsets out to schools and museums, working with young people, showing them 3D printers, 3D technologies, but also talking to them about heritage and uses in heritage as well. So today we're going to be talking about 3D printing. I'm not going to be able to cover everything, but I'll cover like a brief overview and how we've been using it and where we see it going. So a little bit about myself. I'm a director of a 3D design consultancy, Taran 3D, and last 15 years I've been working in architecture and engineering and mainly doing research and development into VR and immersive technologies. I really enjoy kind of 3D modeling things and creating things, especially stuff from heritage. So I'm always doing kind of trying to do creative stuff with 3D, and 3D printing was like a natural kind of follow on from that. Yeah. So if we look at the history of 3D printing as we see today, 1984 was the date that Chuck Hall from America invented a technique called stereolithography. which is a way of using a laser to cure resin in layers to create a 3D model. So that's one of the first kind of 3D print, interesting bit of information. And then a few years later, in 1989, there's a guy called Scott Crump, again from America, who invented fused deposition modeling. And this was a different method where you actually kind of melt plastic and kind of lay on top of each other to create a 3D object. He's actually head of the Stratasys group, and you'll hear about these guys a lot if you're working with manufacturing and 3D printing. So these are the really large type of 3D printers, which kind of most people don't have access to. Again, these are like Stratasys machines. These kind of machines go into the hundreds of thousands, and these are used by kind of large companies who are prototyping kind of hair dryers, consoles and that sort of stuff. So these are really the high end of 3D printers. Yeah, we also have some consumer 3D printers which are becoming more and more affordable. And we're not going to go through all of them, but just giving you an idea that there's lots of different types of 3D printers. These ones are very popular for schools and museums, Ultimaker and the MakerBots. And these range from like the 1,000 to 3,000 mark. And then we've got some cheaper ones, which kind of like the kind of more kind of self-build type models, which can go for anything from £500 to £1,500. And this is where kind of most people are using 3D printing at home because it kind of does what you need. You also got some really cheap ones as well. I mean, there's some very, very cheap models coming out of China. And, we tend not to kind of work with 3D printers which are kind of less than about £800 because we obviously you're getting what you pay for. So what you're paying for is basically the quality of the parts and also the functionality as well of these prints. But we're going to cover that in a bit later. So it may seem a bit kind of complicated at the moment, but we're going to have a look at it. So what type of things do people 3D print? And pretty much anything.
Taryn, just to come in there, there's a question that's come up. It's, what is your opinion of the printers which fuse power together? I'm not sure if that makes sense to you.
What was that again, the question?
What is your opinion of the printers which fuse powder together?
Fuse powder together, yeah, those are the large type of printers and they're very good. The good thing about those types of printers is they don't need any support. So we're going to look at supports later. But again, I think those types of 3D printers, they're kind of inaccessible to most people. And you usually find that with the solutions that I'm going to show you today, you probably won't need to go to that level. Yeah, we'll talk about that in a bit. So yeah, so all types of products will at some point be 3D printed, prototyped this way. They used to be kind of carved and sculpted back in the day, but now 3D printing has pretty much taken over. So what types of things are being prototyped? Obviously game consoles, any types of plastic electronic objects. This was an interesting one I saw online where kind of a bald eagle had damaged its beak and it wouldn't be able to survive, and somebody was able to 3D print a new beak and attach it. So that's interesting. Also being used for prosthetics, 3D print. So some very really interesting ways, innovative ways people are using it. Also for human prosthetics as well. These are really cost effective and people can customize them to the size that they want. So people are kind of developing these at home. They're on normal home 3D printers. Interesting uses in art and in museums as well. So this is an interesting, like an old painting, an old kind of a puzzle painting that was done, and the resulting kind of 3D object that was created from it. Also sculpture as well. There's quite a lot of people using it for sculpture, which is very interesting as well. Costumes and film are using it. So you can see one guy here, he created his own kind of Batman costume. People are creating 3D printed cars and vehicles. Also on the space station, they've got a kind of 3D printer there, which they can print their own little tools. Also in fashion, so some really creative engineering going on here in terms of how they are 3D printing different kind of surfaces and shapes to use. So metal 3D printing is starting to become more and more available, more prominent now, because they can kind of create better parts, more stronger parts, but it's still not kind of mainstream at the moment, and still very large machines and a lot of testing going on at the moment, but it's something that's kind of coming along really well. These new types of 3D printers, which are kind of really expensive, can actually do color 3D printing now. So this is actually a 3D print, if you can believe it. So as it's doing the 3D print, it can infuse inkjet print as well. So you can get really realistic prints. But again, these types of 3D printers are very, very expensive, in the hundreds of thousands of pounds, and used by large companies for doing kind of a lot of prototyping. So service-based prototyping companies. Also, if you look at the, quadrocopters and any kind of custom kind of little mechanics and little objects, people are creating their own custom like airplanes or RC cars. So very big use there of 3D printing. And architecture, more and more now, they're starting to use it to create their models, because you can get cleaner models. So very prominent there. Dentists have actually been using 3D printing for quite a while. So they've been using 3D scanners and printers for a while, but now you can get consumer printers. Before they were really expensive, but now you can get consumer printers which use a dentistry resin. And I'm going to show you one of those a bit later as well.
Yeah. Just got a question from Gurdeep Singh. Would you recommend outsourcing the printing to online printers, or is it something that's better to get your own?
I think it depends, you see. I think it depends if you're going to, if you've got the capacity yourself to do it, then you need to do it. But if it's time constraints, so we do a lot of our own 3D printing, but if there's a time constraint, we will outsource some of it. And I think it depends on where it's going to be going as well. So if you're developing a product, then, and it's quite a large product, then you might outsource that. So it'd be taken on a case-by-case basis. We found that prototyping yourself, so a lot of companies that used to send out their prototyping do it all in-house now, because it's actually quite cost effective and they can rapidly iterate their design very, very quickly now. So, and I'm going to show you an example of that, of what we've done there. So this is an interesting example from the V&A, where they've used a 3D scanned a sculpture, and they created 3 different copies of it. So I thought that was quite an interesting use of it in kind of museums. Also, this is from a church in Italy in 2014. They used it as a kind of low-cost conservation technique to be able to kind of repair existing parts of the chapel sculptures. So things like that, it can really speed things up, because you can take a scan of the existing object and then you can kind of 3D print and minus the object from your object, so it fits very cleanly. So what is the 3D printing process? So we all start over here with a 3D model. You can't 3D print if you haven't got a 3D model, and there's various ways to get a 3D model. So either you model it yourself, or you need to get it from a 3D scan or photogrammetry. The other option is there's quite a few online resources that kind of where you can download existing objects. So I'm going to show you those. So once you've got your 3D model, then there's a bit of preparation involved. You need to make sure that the model is watertight, and that means that there's no holes in it and there's no intersecting geometry. So the whole thing needs to be one shell object with nothing intersecting it. So there's ways of cleaning up your model and fixing it. So I'm going to show you that as well in a bit. And then once you've prepared your 3D model, there's no errors in it, then it needs to go into a slicing software here. And this is where the software, so the 3D printer is actually like a physical kind of creation. So it's actually creating your object in real life. So what it needs to do is it needs to convert your 3D model to layers. So what it's called is layer slicing. So you slice it up into layers. And if you've got any overhangs, you might need to add supports as well. So I'm gonna explain supports in a bit. But what it essentially gives you is a toolpath. So it gives you a toolpath. It calculates where the tool needs to go to actually create this 3D object. Once it's sliced, then this file is sent over to the 3D printer. And this is usually done over an SD card, or if it's got a Wi-Fi connection, you can just send it to the printer straight. And then you also need to monitor the 3D print. Also, once you've finished the 3D print, you might need to remove the supports from it. And then sometimes you might need to do some sanding and smoothing, and then prepare it in whatever way you're going to use it. So we're gonna go through all of these, try and explain them as best we can. So when you're making your 3D model, you can use there's so many different 3D programs on there. These 3 are quite preferred by a lot of the 3D models out there. Tinkercad, a very easy, simple to use 3D software for kids. Autodesk Fusion 360 made by Autodesk. You can get a free version of that if it's non-commercial. and obviously SketchUp, which also has an online free version as well. But these are just what people are preferred, but you can create your 3D model in pretty much any software, so it doesn't really matter. You can use any software. If you're used to using a certain piece of software, then yeah, just use it. And as long as you can create a 3D model, you can export that, and then you can fix it. Okay, so remember we were talking about online resources. There's a couple of websites out there, Thingiverse and My Mini Factory and cults3d.com. I know I'm going through this very fast, but don't worry, it's recorded. So if you need to come back to reference any of this, it'll be on the Facebook page, so you'll be able to access it. So this is an interesting thing. So these websites have loads of 3D models that people have prepared and you can download for free. And just as an example, I'll show you one of the models here. Somebody's actually uploaded an Iron Man MK6 suit, so you can actually download all 92 files, and then you could start, and they're ready to print, so they're STL files, so they're already prepared. You can just load them onto your 3D printer, and if that's what you want to do, then you can just go for that.
Taryn,
So,
just got two questions that have come up. One is from Gurdeep Singh again, saying, have you used the new iPad LiDAR sensor to scan any model?
I haven't used it. I've heard good things about it, but we use a handheld scanner. And even if you are scanning anything that you are scanning, it's still going to need a bit of cleanup. So you will get some decent, you might be able to get some okay-ish kind of 3D models from it. But I haven't seen anything that's been like production, you know, that is on the level of a production-ready 3D scanner. I'll show you an example of a 3D scan in a bit, actually, so you can compare. But I haven't seen any examples of any 3D scans from it at the moment.
Brilliant. And the second question I had was from Kamaljeet Chana. How optimized does the 3D model have to be before printing? For example, could you throw a model straight out of the ZBrush to STL file and then print it?
Yeah, pretty much you could. ZBrush is really good. We use it quite a lot because in ZBrush it actually has a 3D print exporter built into it. So as long as you kind of you make sure that there's no holes in your model and that there's no intersecting geometries, as in you dynamesh it, then you should be able to just from the 3D print exporter in the plugins just export it straight out. And we do that a lot. We use ZBrush a lot for our type of you know. So yeah, you can pretty much from ZBrush export a model out and get it to 3D print. The place where you're going to need to optimize your 3D model is where you've got like overhangs and supports are needed and where the parts are too thin. So that is something that you just learn as you go along and you start to pick up actually this is too thin to print. And I'll show you some of that as well. So a lot of these examples will come up. So another way of getting your 3D model coming in is 3D scanning. So as you can see, somebody's 3D scanning here. On the right is a 3D scan that we did of a starfish. And so even though you can 3D scan, you'll find that there's still a bit of cleanup work that needs to be done on the 3D scan. You know, so there'll need to be holes closed. You may need to do a bit of sculpting. You may need to kind of merge two different sides of the 3D scan together. So there's some work involved there, but it's a way of getting your 3D models out. The other way to get a 3D model out is to use photogrammetry. So this is where you take loads of photographs of an object, and this is at the V&A Museum. Me and Grinda went down, we took loads of photographs, and we generated this 3D model. And as you can see here, you've got these kind of like photographs, and these are kind of like projecting onto the 3D model, and it's calculating where the surfaces are. It matches all the photographs, and then it can create a 3D model from that. So really interesting technique. A lot of people are starting to use it, becoming more and more accessible because camera phones are becoming better quality. So there's 9 different 3D print technologies. There's probably a few more that are coming in as well. But the ones that we're going to look at are these two. So the stereolithography one and the FDM one. The one that we're kind of more used to, the one that everyone is using more or less in schools and colleges, most places, is FDM. And don't worry about understanding it. I'll explain it all. So 2 different types. So you got FDM, which is basically melting a thin line of plastic through an extruder and then laying it on top of each other. So that's fused deposition modeling. And the other one is SLA, and this is slightly different because what it's doing is it has a vat of resin, and a platform comes down, and then a laser from underneath actually cures the resin. So I'm going to show you this. So if you look at FDM printers, this is a typical FDM printer. So the way that this works is you've got your kind of a spool of filament here. So this is called the filament. And this is usually, you've got different types of filament, different colors you can get. And it's basically like a small wire of plastic. And then this basically drives into the extruder here. So this part here is basically the extruder. Okay, now essentially how this works is we've got a bed here. So this is usually heated. And this is where your 3D prints will actually be placed on. So the way that this works is this extruder here can actually move left to right. Okay, so it can move along these wires here. It can move left and right, and this gives you your x-axis. So it can move in this direction, and then these sliders down the side here give you a z-axis. So that's the z-axis here. So the x-axis is here, where it's moving there. The z-axis is over here, and then this actual bed can actually move backwards and forwards. Okay. Now what that essentially does is it means that this extruder here can actually move anywhere. So I'm drawing this really badly, but anywhere within this kind of box kind of shape. So you can move anywhere, and the tool path is actually guiding this extruder along these paths. So that's basically FDM. Fused deposition model. You don't have to remember it, but it's just if you understand what it is that you're trying to do, and you understand what the technology is, then you know what you're trying to do. So essentially, what this extruder over here is doing is your plastic will come through here. There's a motor on here which drives the plastic through. It goes through this extruder here. It heats it up. So this is where all the heat is. It heats up the plastic, melts it down, and then you have your nozzle over here. And it's usually like something like a 0.4 millimeter nozzle. You can get different sizes, different types of make, and a thin line of plastic actually just comes out of there. So it's quite simple, really. There's nothing major going on here. This is actually what it looks like. So you can see the nozzle is going over the tool path, and it's slowly building up that structure. And this is actually a video you can see clearly there. The nozzle is actually squeezing out the plastic, and it's following the path that the tool path has given it. And slowly, it just builds up this shape. Okay, so on this 3D print, you can see here that you can actually see the layer lines, and this is like a characteristic of FDM printing, is that you will get these kind of little striations on the print. That's because these layers are kind of like melted on top of each other. And this is one of the issues that you will get with most FDM printers. You also have different types of infill. So you wouldn't like do 100% filled plastic 3D print. It would take you ages. You would use something like a 10% fill, or like a 30% fill, or like a 90% fill. And then it depends on how strong you need the part. Most people, if you're just doing aesthetic parts, you can just go with 10%, and it'll save you a lot of plastic and time as well. Okay, so this is one of the issues when we were talking about optimizing your 3D print. This is the problem with most 3D printers. They actually layer on top of each other. So they're layering on top of each other. The problem is when you get to this point here, and then you've got a ledge coming out here, there's nothing for the plastic to lean on. So the plastic is going all over the place. So what we use something, well, there's two ways of getting over this. One way is actually you make a design change. So as somebody asked earlier about ZBrush, this is what we tend to do when we're doing 3D modeling and we have an overhang. We tend to kind of build it out like this. So there's always, it's slowly building up that base so that it can slowly come out like this. So you could, that's one of the design changes you can make. If that is not an option, then you will use something called supports. Now, as you can see, this is the skull that I modeled, and then when it was 3D printed, I actually oriented it facing upwards. And the reason for that was because the supports here, so you can see it's kind of, and supports are just kind of like useless bits of plastic that just hold up your object. So they're very thin, and then they're basically just here holding up this side of the chin, holding up this side of the jaw, and then you've got it a little bit here just to support that side of the skull there. And this is a FDM support, so this is how they'll be done. And you want to put the supports where they're not going to be seen, so you try and hide them wherever you can. On an SLA print, which we're going to look at in a bit as well, these are the supports for SLA print, and you can see they're very different. They're very thin, and this is because it uses a different printing method. This type of support would not work on it. So you can see the 3D print there, the 3D model there, and how it's been turned into a 3D print. And as you can see, I put the supports on the flat edge So I'll put the supports on the flat edge here because they'll be easy to stand off. Okay, so different types of slicing software, there's loads of them out there. When you get your 3D printer, it will probably come with one, and there's loads of free ones out there. I tend to use Simplify 3D because it gives me a lot of control over kind of the prints, and you're going to see some of those coming up soon. So we talk about filament types, the different types of plastic that go into the 3D print. Mainly, most people will be using PLA. It's the easiest one to use. It's biodegradable, and it's cheap and easy to use. You do have other types of materials like ABS, which is they have different characteristics. ABS is a bit stronger, but the thing is, it's harder to print because you have to control the temperature a bit more because it tends to dry a bit unevenly and shrink, and then it can create kind of problems. So we kind of recommend beginners stick with the PLA to start off with, and then move on to other types of material. You can get other types of material with wood, metal, and carbon fiber, but then you have to change your nozzle as well. You have to kind of make some modifications to your 3D printer, like change a few parts just to be able to handle that type of material. But PLA is really versatile, really easy to use. It's not very strong, and it doesn't do very well under kind of sunlight, so it's not going to create, you're not going to be able to create outdoor sculptures with it. Obviously, you can get different colors and obviously different types of materials in there as well. If you're interested in different types of materials, then there's a really good guide on simplify3d.com with a good materials guide. Just do search for Simplify 3D Materials Guide, and you can get an idea there. So you've got different types of plastic infused with particles of marble, particles of wood. Okay. So now we come to the SLA type of printing. So we all kind of seen probably the FDM style printing. Now these kind of SLA printers, these are quite, these were the first type that were designed, but they've been so expensive, they've only really become accessible recently. And the way that they work is basically you have your platform, and the platform basically goes into, you can actually see the vat of liquid here. So you get this, it's wiping the resin away. So this arm wipes the resin away. The 3D model touches the surface there, and then there's a laser at the bottom which is actually kind of curing all the different layers. So it's a different style, yeah, and we're going to have a look at comparison actually between the two and what the difference is between the two. Okay, so coming on to how we've been using 3D printing. So this is some photographs that Grinda went and took from the V&A Museum of some arrows. We created our own 3D models from this. So we created some quick 3D models, and then we kind of did two types of print. We did an FDM print. So this is Simplify 3D. This is showing you all the different layers. It's showing you the infill in orange. It's showing you the outer layers, and it's also showing you, see, you can see the supports here. So you can see the reason those supports were required is because, see these edge bits here, they would have kind of just fallen down, and we've got some supports here as well, and supports here to hold up that bit of plastic there. So that's the FDM print, but if we were going to do that in SLA, how does that differ? So SLA obviously has different types of supports. So these are a lot thinner, and they're plastic, and then they kind of connect in here. So here you can see the difference between like an FDM print and an SLA print. So you can see here the plastic's been melted on top of each other, and you can see these lines here. And if you look at the SLA one, you can barely see the lines. I mean, it's pretty, I mean, I haven't done any cleanup on there, and I even left in the supports on this because I just took the photo quickly, but you can see the difference in quality. But just to give you an idea, the model that printed this was, sorry, the 3D printer that printed this was £800, and the 3D printer that did this was £3.5 grand. So it gives you an idea of the different types of quality you're getting for the money that you're spending. And just to give you an idea of what the difference was, so in FDM it was 1 hour 33 minutes, and in SLA print it was 4 hours 30 minutes. And also, if you look at the material cost is very key, because on the FDM it only costs 13 pence, but on the SLA print it actually costs £1.18, and this is a relatively small print, so you can understand if it gets bigger, then I mean that can get really big, the cost can. But it gives you a really good idea of the type of cost. So this is when we went out to one of the Leicester museums, New York Houses Museum, where we did a 3D print session with kids. And we were able to 3D print these badges and medals for the kids and reproduce them and give them out to the kids so they could paint them. and they had something to take away with them. So a really good way of creating like physical objects that you can give out, very cheap, obviously done on the FDM printer. And it's a really good way of kind of engaging young people. So you've probably seen this as well. This is the Jirena that we modeled. So I'll open this up and you can see this on our website here. So if you come here, you can actually start this and you can actually start looking at this 3D model. So this is on our website. So we had the model and we thought, what would it look like if we tried to 3D print it? And this is actually the 3D print that we did in SLA. It's not very big. It's only kind of like about 8 inches tall, but you can see that it actually picked up all of the detail from the 3D model, including the text. So it's a very interesting kind of proposition there in terms of being able to recreate, historic objects. So this is a 3D scan. So I talk about 3D scans. So this is a 3D scan touched up in ZBrush and then exported straight out to the 3D printer. And this is an FDM print, and you can tell because you can see the lines on this. But from far away, you can get a really good effect with this sort of print. This is an interesting project. This wasn't 3D printed, but this is really interesting. So we had somebody from India, Hajur Sahib. And in the Takht Hajur Sahib, they have a frame for Guru Gobind Singh Ji's photo which was painted by Hari Singh in the early 1900s. And the frame there was made of wood and it was warping. So there's by Inderjeet Singh Man from Abu Dhabi, Dubai, he contacted me and said, we'd like to do something. So basically they they did a 3D scan of the original one, and we were able to kind of straighten it out, resculpt some of the detail, bring back some of the detail that had been lost, some of the piping and work. And we were able to send this to kind of Italy, and then it was kind of made out of a composite of 2 metals and then plated in gold. And you can see this actually, it's installed at Hajur Sahib at this moment in time. So it's really interesting. We're using the same techniques, but not using 3D printing. I think this is using a subtractive method, either CNC or something like that, but it used the same technique that we used for 3D printing. And I could probably print these out on I could probably print this out on my machine. The only problem is my machine can only print about that size. So this is one consideration that you have to take, one thing that you have to take into consideration is that your print size is going to be very small. Again, Harmandir Sahib, we did a 3D model of the one of the domes, and we were able to 3D print it. And this is done on the SLA printer, and we hollowed it out to save money on the resin. But you can see you can get a really good kind of output from it.
Taran Singh, we've had some interesting questions that have come up. Melissa Hawker has asked, how do the different methods compared in terms of standing up to handling, with the different materials and the printing? Is there a difference that we can see?
Yeah, so I would say with the FDM printers, they're quite cheap, so you don't mind if the kids kind of mess about with them or kind of damage them, because you can just 3D print another one and it's 13 pence. But and so it's quite cheap. But the SLA prints, they're quite solid as well. The only problem that you get is with very thin parts. So these kind of sharp bits here aren't very, very strong, so they would kind of like fray quite a bit. But we did prefer the FDM prints because obviously it's not as sharp as these ones. These wouldn't cut anyone because they have been rounded off. But yeah, no, they handle really well. I mean, you can give them to the kids; they can play around with them. They do break. They will break and snap. So we have had a couple, when the kids are playing around with it, they will snap them. But I mean, that's just you having to kind of obviously manage the way the kids are handling them. So 3D prints aren't really massively strong, but they're quite durable if they're looked after. And
had a question from Cook Singh. Are there STL files that are you can offer out to people so that they can print them at home?
Yeah, so like I said, the online resources are really good. I've got a couple of models online. I've put this model online as well. Actually, the one on the screen at the moment, it's online on Cold Street. I think you download it for free. So yeah, so if you look on Thingiverse, you'll find pretty much a lot of stuff, and you can download it and modify it. And I think we'll probably be releasing some STL prints soon as well. So this is just an example of rapid prototyping. So this model I did for a friend of mine. He likes motorbikes and stuff, and he wanted something for the front of his motorbike. But this was kind of modeled in ZBrush in like 3-4 hours, and we were able to do a 3D print of it within it took 7 hours to 3D print. And the problem here was that I did the kind of teeth here too thin. So basically, they would break off. So you know, you're talking about the handling. Something like that that's really thin, that's very easy to break off. So the way I would modify this is I would make them a little bit thicker, or what I would do is I'd print this off as a separate piece, and then attach it with a bit of a wire attachment, and that makes it a bit stronger. So you can see here there's quite a bit of supports around here, so loads of supports around here to support the kind of head, and inside the eyes there's supports as well. But you can clearly see inside. You can see the sort of pattern inside that it's kind of 3D printing. So this is another example. Yeah. So this is another example, and so this was straight off the print. Sorry, this was. Oh, sorry, I'm going the other way. Yeah, so this was straight off the SLA printer. We just put one coat of paint on it, and I've actually got an example of this in the software. So this is how you'd put it into the software, and then this is how it kind of works out the different types of layers. So you can kind of rearrange it. I can change the scale of it and things like that. So I could say, you know, change the scale to 0.5, and then I can say, okay, that's the size that I want, and then print generate supports for it. And then it will give you an idea of like how much kind of time it's going to take. So that's 6 hours. So originally it was a 30-hour print. So by changing the size, it's changed it to 6 hours. So I won't continue with that. So again, we're looking at detailing of costumes and things like this. If you are looking to get detail like this out of your 3D prints, then you need to use the SLA method, and it's a little bit more costly. We've been doing quite a bit of sculpting and doing a lot of like historic, you know, kind of clothing and weaponry and stuff like that. And we've been able to 3D print really successfully. This, you know, this is one of the statues that I made in 2016, and these, you know, we did a Kickstarter for these, and they were quite successfully kind of gone around the world. So you can get really good. It's a really good way to kind of prototype and test. And we did like loads of tests. When we started this, I was having to send it out, and the test come back a couple of days later, and it was quite expensive. And then I'd send another test out, and it'd come back. With having a 3D printer at home, it's very cost effective. You send off a 3D print, come back the next day in the morning, and you've got an idea. So what we recommend, what we usually recommend is use the FDM method to prototype. And then once you're happy with the sizes and the style of it, and then go to the SLA print for your master. And then from your master, then you can actually create, so this is actually silicone rubber. So if you want to make loads of copies, 3D printing is not a mass production technique. It's more of a prototyping technique. If you think you're going to be printing thousands of badges off it or thousands of statues off it, that's not going to happen. What you tend to do is prototype, create a master, and then you'll use traditional casting techniques by using silicone clay, and then from that you can actually make resin copies. So you can make quite cheap kind of resin copies here. These are a couple of other models that we've done again on the SLA printer. And on this, you're seeing even some of the cloth folds that come out. So you see with the SLA, it's very, very detailed, where, you know, if we did this on the FDM, it wouldn't really come out with this amount of detail. It would really struggle with this sort of stuff. So understanding, because this is the problem that we have a lot, is that people buy an FDM printer, but they expect SLA output, and that's not going to happen. So it's interesting to understand what the different types are, and they're the most kind of common ones that everyone's using. This is another type that we did quite early on, again on an SLA printer. We prototyped it heavily on a FDM to start with, because it's very cheap, quick to iterate. This is an interesting final project that we're going to share now. So this was for a school in London. They wanted like for the Nishan side, they wanted a new design rather than just a typical kind of cheaply bought like Indian metal beaten kind of kanda. So we did a custom design for them. And as you can see here, it was actually it wouldn't fit on the printer, so we broke it up into 3 parts. So here you can see I'm actually filling it and sanding it down. So you can get really clean prints from an FDM print. It just takes a bit of work, a bit of sanding. You can sand a PLA, you can fill it, you know, with a bit of wood filler, and you can glue it together quite well. And from this, you know, we were able to create like a finished piece paint it in, spray it in like a metallic paint, gives it a bit more kind of safe protection, and that actually went up, and it's actually should be actually still at the Artham Academy on the Nishan side at the top. So it's a bit of custom design and prototyping, you know, really, really cool. And we could only do that because we had 3D printers to be able to do that. So what could go wrong? A lot could go wrong with 3D printing. Sometimes your bed is not level, sometimes the material gets stuck, or sometimes it catches on something, or the temperature is too hot. And so, you know, loads of things can go wrong, but I say, you know, give it a bit of time. It's going to take a bit of time to get into it. And this is my advice for beginnings, and this is where we're going to finish. So just to understand, it's going to take time, it's going to take a bit of experimentation. There's a lot of things to understand there. I mean, I've brushed over a lot of stuff, but there's loads of things to kind of learn slowly, and it's quite fun and interesting. And I do it with the kids as well. I get my kids to do 3D models and 3D print. It's a fun way to learn. Get started with an average price 3D printer. I mean, don't go too low, because the lower you go, the more problems you're going to have. At least get something with like automatic bed leveling. I prefer the Prusa printers because they're really good workhorses. They got really good reviews. If you go onto YouTube, you can get really good kind of reviews for all the 3D printers. Look for people who are doing the similar sort of stuff to what you want to produce, and then kind of like buy the sort of equipment that they're using, or slowly work your way up towards it. I would say keep it simple to start off with, and stick to PLA, simple materials, simple 3D prints. Print small and do loads of tests. So you're printing small, looking at the quality, changing little things. So we haven't gone into kind of the 3D slicing settings, so you can change the layer heights, you can change the thickness of the walls, you can change the infill. Download and print existing 3D models, because that's a good way for you to compare how you're doing against other people. So there's loads of test prints out there. A good thing to do is start to learn 3D modeling, because it's nice to model other people's prints, but it's brilliant to actually start creating your own stuff and make your own 3D prints. Calibrate your 3D printer often, because it's kind of like a physical process. It's not like in the computer where everything's straight and everything, you know, your table could be a little bit offset, you know, the bed level could be just 0.1 mm down and it needs leveling. So just learn about your 3D printer and how to do that, how to clean it and maintain it as well. So that's really important. Clean and lubricate your 3D printer, because you know, it's using motors, it needs oiling, you know, it needs lubrication and that sort of stuff. And yeah, I think we're going to finish there. I think I've tried to cover as much as I can. Now we'll try and answer some questions now.
Brilliant. Thank you, Taran. That was a really informative presentation from yourself, and it's really appreciated to have your expertise and opinion to share with us and give your insights. A couple of questions that have come through. If anyone does have a question, if you just pop them into the chat. But Gurdeep Singh has asked, the content that you've made for the Artham Academy, in sort of average British weather, how long would that last?
Well, if it was just PLA, it would probably only last, like I'd say, about 6 to 8 weeks. But because we put a metallic layer on the outside of it, you know, and we put basically, first of all, we put a primer on it, and then we use basically automotive paints to paint it. Automotive paints are very durable, used on cars outside. So we used a metallic automotive paint, and that basically means it could probably last a few years.
Excellent. And Cook Singh's asking, could you recommend a reasonably priced SLA printer?
Okay, so this is really interesting now. So if it was a year ago, I would have said like the Form 2 printers, the Form 2, you know, the Form Labs SLA printers. But actually there's a couple at the moment, which are out there. If I can remember the name, there's a Phenom one, which is a really large one, which is very, very good price. And then there's I can't remember the name of it, but I can find out and I'll recommend, but definitely have a search around. I did have it up on here actually. Let me just see if I can remember the name of it. Ah, yeah, found it. Yeah. So so there's one called where's the name of it? Yeah, no, I can't find it at the moment.
Well, if later on the Facebook page, you can just pop it into the chat there.
Yeah. Oh yeah, sorry, I've got it. Yeah, there's an Anycubic Photon, So that's what it's called. It's a funny name, so I couldn't remember it. Any cubic photon is very good, very reasonably priced, and the resin is really cost effective as well. And then there's a Phenom. It's companies. I think it's called the Phenom L. And I mean, it's crazy because they've just come up with a new one, and it's absolutely huge, and it's an SLA printer. And yeah, Phenom L by Pure Poly. So if you check those two out and then compare it to the Form 2, but the Form 2 is like industry standard. A lot of businesses out there are using it, and they've got loads of different resins for it. So if you can afford it, I would kind of go for Form 2. That's what we use. But you know, if you're on a budget, the Phenom and the N-Cubic are really good as well.
Brilliant. And a question from Ruth Rignall. What would you recommend for a reasonably priced FDM printer, and how long can FDM material last for?
Yeah, so the one that I recommend the most is the one that I found, because we recommend to a lot of kind of like schools and colleges and places like that. And the one that I recommend is the Prusa printers, because they're like the best reviewed. If you look at a lot of reviews online, it's got, you know, it's one of the best 3D printer for a long time, very cost effective. You can get a kit for, I think, about £700, and you can get it. So I got the kit and built mine. And I mean, I can only speak from experience. There's probably a load of really good printers out there. But I found with the Prusa, it's the one that needs the least amount of kind of work to kind of get going really fast. So I would recommend those. And the PLA, kind of pretty much, if you're just using them indoors or you're just having them around, the PLA material can last, you know, I've got 3D prints from 4 or 5 years ago that's still fine. They've not been exposed to any excess heat or been in sunlight. They'll last quite a long time. If you want to, if you're looking to kind of print objects for a certain place, or you want them to go out, or they're going to have a bit of load on them, or then you would start to kind of move towards ABS material or PETG type materials, which are more stronger. So you can kind of customize the material that you're using to the use that you're going to have. And most 3D printers will allow you to use different types of material. The only thing I would say is to be careful of is just that when you're, I would practice with PLA because it's a very good introduction, and then move on to ABS, because ABS is a bit more involved, where you're going to have to control the temperature of the plastic and you know, kind of watch it a bit more closely as well.
Brilliant. And a quick question that we had personal to you, what printers do you have?
Okay, so what printers that I use, like I said, is the Prusa i3 MK2, and I'm going to upgrade that to the MK3S very soon. So that's the Prusa printers. They're based in Czechoslovakia. And also the other one that I use is the Form 2. Now the Form 3 has already come out, but the Form 2 does everything that we need. And those are the two 3D printers that you need. Sometimes when we do a lot of work for like people who are inventing new products. So we 3D model and 3D print prototype their products for them. And sometimes what we do is we usually we outsource some of our 3D printing. So there's a couple of 3D print, you can go to 3D Print Hub, but I found them to be a bit expensive at the moment. But if you can find a local 3D print shop, you can usually, if you have an excess, you can go to them. But I think it's a good thing to start doing little things yourself, start doing, you know, we've been printing actually COVID masks as well. So we've been doing COVID for COVID-19, so with the virus situation, we've been printing PPE masks as well. So we stack them 4 on top of each other and 3D print them. And doing things like that, you know, you can learn a lot by doing.
Brilliant. Thank you ever so much for your presentation, giving us your time this evening. There's lots of comments that are coming through showing appreciation to how exceptional your presentation was and how interesting and informative it's been for all of us listening here. So thank you ever so much to everyone listening.
If anyone's like needs any help or advice or anything, just feel free to contact. You know, our contact details are all online. Get in touch, and you know, we can kind of, you know, we're happy to give people advice and help out.
Brilliant. So just to close now, thank you ever so much to everyone who's joined us this evening. Thank you, Taran, for leading on this presentation and sharing your expertise and information. For those of you who don't know much more about the Anglo Sikh Museum project, I can tell you our website, which is www.anglosikhmuseum.com, where we are hosting some of our objects that we've recreated in virtual reality. And coming up, we have some exciting objects that will be uploaded onto the website. So do keep checking that out. whenever you can. So one, it'll be the Satluj Medal, which was received by British officers after the first Anglo Sikh Wars, and coming up soon will be a Khalsa flag that was used during the Sikh Empire. If you have any questions, please just drop us a line on info@sikhmuseum.org.uk. That's info@sikhmuseum.org.uk. And if you have any additional questions, and just either send them onto our email or pop them onto the Facebook video, and we'll try and respond to them. So the Virtual Reality Museum, the Anglo Sikh Virtual Museum, is funded by the National Lottery Heritage Fund, and that's been instrumental in helping us bring this project about. And if you have any suggestions or ideas for things you'd like to see from us, or areas or topics that you'd like us to cover, please do drop us a line, because I know we're always trying to respond to what people are interested in. And it'll be wonderful to have you here again another evening in another webinar coming soon. So thank you ever so much. I hope you all have a wonderful evening. Stay safe and be well.